Alright, for this last problem on scalar multiples, we've taken a look at two others already in previous videos. Now for this third and final one, we're going to take a look at one that is provided to us in a direct notation, where they give us the magnitude and the direction. So here we see that our magnitude of our vector b is 17, and our direction from the positive x-axis counterclockwise is 73 degrees. So if you wanted a quick sketch of that, you would see something that would be a little higher up in the first quadrant like this, with a magnitude of 17 and an angle of 73 degrees. You don't really need that sketch there, but just kind of keeping a general eye on this. This is also assuming that we are orienting everything from the origin. And that's how I tend to draw these when they're just in a vacuum like this with no context. So it asks us to find negative 3b. In this case, that means take whatever your b component is and multiply it by negative 3. Now, in a way, you could easily just say, oh, well, 17 times negative 3, and you could get your magnitude for b. But notice they do ask us for component form, and I usually recommend working from component form in most of my problems. There will be times where maybe it's faster to do something else, but for this problem, I think it's good review. We should go ahead and find bx and by. The nice thing is if you're given direction like we've been given from the positive x-axis and counterclockwise, all you have to do is take 17 times cosine of your angle, or I should say the magnitude times cosine of your angle, and 17 sine of 73 in this case. And those two values that I get here are going to result in my x and my y components. Now I'll likely have to round these. That's not a huge deal right now. But let's go ahead and just figure out what those values are. Always double check. So my calculator is in degree mode. So we're just going to real fast type these things in. We get cosine, and I'm just going to do a second enter and scroll over and replace with sine here. That's how I prefer to do that. It's not really required. You can just retype it. So we're seeing about 4.97 and about 16.26 for those x and y components. From there, if you remember from previous videos, all you have to do now is multiply these two values by negative 3. So just to be clear here, we'll just write this down. The vector b is the vector 4.97, comma 16.26. Notice they're both positive because we're in the first quadrant. 3b just says multiply those by 3. So what I'm going to do to make sure this is as accurate as possible is I'm going to hit enter on this to re-enter that statement and then just multiply that result by by negative 3, I should be careful. And we'll get negative 14.91. So negative 14.91. This is why I like having a calculator like this to do these problems. If you don't, it's okay to just retype these things in, but this saves me a little bit of extra typing along the way. And so now I'm going to get negative 48.77. Now doing it this way in the calculator does allow me the ability to minimize rounding error. What I mean by that is that these answers up here could have been slightly different if I had not rounded. Now I put a negative there on both. That's good, just making sure. Wanted to make sure I didn't leave one off. As an example here, if I had multiplied this one by negative 3, the way I've rounded it here, we'd get a slightly different answer. It's very minimal, and in this problem, maybe that's okay. But in general, you do want to be careful about rounding because in some problems with larger numbers especially, that rounding can take your number and shove it way out of proportion.